Now let me continue with this general framework. Now in this general structure, the first thing that I will do is talk about the centralized problem. In other words, what happens if the supplier and buyer are part of the same firm? So that's the centralized solution. So in that case, what we have is the following. So let me, before going further actually, let me give the notation related to all of these. So what we have is we have the supplier and we have the buyer. Now there is some kind of a relationship between these two. The supplier is going to have a manufacturing cost of C per unit. So this is unit cost C. And the manufacturer is going to have, there will be actually in this system, there will be three different flows. One of them is the so-called material flow. The other one is the information flow. And the third one is the financial flow. What do I mean by financial flow? There will be some monetary transactions in between this buyer and seller. So let me start with information flow. And in that case, the buyer is going to order Q units. This is the ordering information. And then the supplier is going to ship Q units. So this is basically the material flow. Okay? And the buyer is going to sell the minimum of Q and demand, which is, let's say, a function of the price. Okay? So D of P is a random function, but it is a function of the selling price, where P is the selling price. Now, I'm not going to consider the case where P is also a decision variable, but we can follow, it's the same idea. And the retailer, on the other hand, or the buyer, excuse me, is going to pay WQ for the ordering quantity. So this is going to be total amount paid for ordering Q units. And of course, this is going to be P is the price per unit, and this is also going to be a financial flow. Now, of course, at the top of this, you can add the following. For example, if the supplier buys, if there is a buyback contract means that anything which is left here is going to be bought by the supplier. In that case, the supplier is going to pay some money for the amount which is left over. Or if we have revenue sharing contract, the way that these are going to be charged will be a little bit different. But what is the idea is that there is some kind of an information flow. The information that flows actually from the market is about the demand function. So the top level is the information flow, demand function, quantity ordered. The middle level is actually the physical material flow. Q is flowed, and then you satisfy customer demand. The bottom part is the financial flow. Okay, financial flow from the market to the buyer, financial flow from the buyer to the supplier, and the financial flow from the supplier for its own costs. Now, you can generalize these by making all the flows a function. Note that all the flows are actually decision variables. They all have decision variable part or a random part. For example, what happens if the supply is uncertain? Okay, we didn't talk about those type of problems, but there are certain cases where the quantity which is going to be supplied by the supplier is uncertain. What are the reasons for this uncertainty? Well, there might be some flaws in the process, some errors in the process, where the quantity that is manufactured is not necessarily all going to conform with the standards. So what happens is that Q units are transferred from the supplier to the buyer, but only a certain proportion of it is usable. Okay? In that case, we call this supply as random supply. So it means that you order Q units, but you might receive less than Q units. Now, knowing this supplier is going to ship more, actually, this is the way that it goes in practice. So as a result of ordering Q units, you may receive more than Q units, which are all conforming the standards, or you may receive less than Q units, which are conforming the standards. So there is always randomness in there. Now, the quantity which is paid is not necessarily going to be per unit basis. It might have a fixed part. Okay? So you can see that looking at this type of a picture, you can generalize the transactions in between supplier and buyer. And there are actually many studies which does this type of relation. Now, we are going to take a more simpler track, and we are going to say that let demand be now another thing, excuse me, before going further, another thing is that we assume that price is set in the market. Okay? So price is not a decision variable. Whereas in reality, price is going to be a decision variable. And depending on the price, you are going to have a different demand function. Remember the courses that you took in from the economics department. Okay, but you might still have randomness. That's something else. Okay, randomness might still be there. But given a certain price, your demand function is going to be different. And usually as price increases, demand goes down. But again, for the buyer, not only the quantity Q is a decision variable, but at the same time, P might be a decision variable as well. What should be the price that I'm going to set? Okay? Any questions on this setting? Now, given this setting, actually, I'm going to simplify the setting by saying that price is exogenous, which means that it is given by the market. So there is no possibility of determining the price. It's given, and it is going to be used as P. Now, given this, how are we going to evaluate different contracts? So that this is what we are going to see now. Now, again, I am assuming that we have a very simple problem where we have a single period for which we are going to satisfy the demand. In other words, this ordering is done only once, okay? And this is the way that we are going to formulate it. So let us say that f of x is the demand PDF. And of course, now we are going to have the news vendor problem. So let me call pi of C as the expected centralized profit for the news vendor problem. Now, what do I mean with centralized? When I have the centralized problem, I'm not interested in this quantity here, the financial flow that I have in between buyer and supplier. Okay? Because I am thinking that this is a single system, so whatever I pay to the supplier is basically the money that I put from one pocket to the other. Sometimes this is called the transfer price. transfer price is not going to have any meaning if we're talking about the centralized system. What will be important is the total quantity that you order and you sell in the market, because you make the profit accordingly. So given this centralized system, this is a news vendor problem. So if I write pi of C, this is simply going to be minus C times Q. Okay. Then I'm going to have, if the demand is in between 0 and Q, I'm going to sell and receive a revenue of P, f of x dx. For each x, I'm going to receive this revenue. And if the demand is larger than Q, I'm only going to receive the revenue for the Q units. So this is going to be P times Q f of x dx. Okay, this is the centralized problem. Note that I don't have any salvage, so on and so forth. I don't think about this, but basically this is what I have. Now, what is the optimality condition? Well, we know that it's the fractal, and so I'm not going to write. But what I can do is I can rearrange this term and write this in a more structured way in the following sense. So pi c can be written as P, the price, times the expected value of minimum Q and D. So this means that you are going to receive the revenue for the items that you are going to sell, and the item that you sell is the expected value of the minimum of Q and D, okay, where D is the demand, Q is the quantity which is available. Then you have minus CQ as the cost. Actually, I can write the whole thing in this fashion. Remember, this is actually the first step, actually, before you obtain the integral. Now, I'm going to operate with that centralized profit. So this means that if I had a centralized system, I would select Q optimally. And how am I going to do that? Well, I'll take the first derivative of this, obtain Q value, and here FQ star is simply going to be equal to C divided by P, if I'm not mistaken. Yes. Okay. So this is going to be the optimal solution. Okay? Why? What is the cost of underage? If you cannot sell an item, okay, you are losing the profit. So CU is P minus C. The profit that you are going to obtain per unit is P minus C. CO, cost of overage, is what? If you cannot sell an item, you are going to pay the manufacturing cost and you don't have any salvage. So this is simply going to be C. So CU plus CO is going to be simply P. And this is, going to be P minus C. Okay. So CU divided by CU plus CO is the percentage, is the fractal that we are looking for. Okay. Now, let us say that I'm operating with the optimal centralized Q. So let me put a star there so that now I'm talking about the optimal profit, expected profit for the centralized system. This is the maximum expected profit that you can get. Any questions on this? Okay. Now, recall the relation. Let us now assume that we have a wholesale contract. By the way, again, going back to this formula, if you really want to generalize this formula, this part is always going to be Cu plus Co, and this part is going to be CO. So this is the way that actually you can write the expected profit function or expected cost function of a news vendor problem. Okay. Anyway, okay. Now let's look at a wholesale contract. What do we mean by a wholesale contract? Wholesale contract is very simple. Retailer or buyer pays W per unit to the supplier. Okay? So remember the flows. I have written here as W of Q, and it's a linear function. It pays W for each unit. So how does this happen? The supplier announces a wholesale price, okay, and retailer buys everything according to this wholesale price. So now let us see what is the profit, and now I'm going to write the profit as the decentralized expected profit. So I'm going to have pi superscript D of the retailer. Now again, we are going to have the same form with the exception of what? Now the unit cost for the retailer is going to be W rather than C. C is not going to be apparent in this formula. So if I write the news vendor equation for news vendor problems for the decentralized system for the retailer, what am I going to have? Just looking at this, I am going to have P again for the items which is sold. So P times the expected value of minimum Q D, okay? This part is still going to be the same. In other words, the revenue that the retailer is going to receive, the buyer is going to receive, will be exactly the same if Q was the same, okay? The structure is the same. For each quantity that you sell, you are going to receive a price of P. Minus, what am I going to have here? Now I'm going to have WQ. Now we're coming to the part where we set up the analogy, actually. So this is decentralized, and let me write here as the buyer, because this is the profit function of the buyer. Now, when you look at this, in order, excuse me, I have a start here as well. Okay. And if we look at this, what we want is we want the same Q star to happen in the case where we have contracts. In other words, if we really want the supply chain to be coordinated, now what do we mean by coordinated? Coordinated means that we want to achieve, with the decentralized solution, we want to achieve the centralized solution, and that is what we mean by coordination. Remember, that's the way that we defined it. Okay? If we want the supply chain to be coordinated, then the Q value should be exactly the same Q value that we obtained there. Now, what is the profit of the supplier in this decentralized case? Okay, can you tell me what the profit is? Okay, W minus C times Q. Okay? So this is the profit of the supplier, because regardless, the supplier is only reacting. Remember, if you give me an order of Q, I'm going to manufacture an order of Q. So given this, actually, in order to make the optimal decision of the decentralized part, note that this is basically a reaction function where Once Q is given, you simply compute the profit of the supplier. The supplier doesn't have anything to do with the total profit. Okay? So which part is going to affect the profit? The decision that you give is going to affect the profit. Now, if you want to give exactly the same decision as the centralized system, what should be the value of W for the retailer? Okay? So let's say that we want to have our Q, we want Q to be the Q optimal of the centralized. Okay? Now, if you want to have that, this is the newsboy structure. The buyer is going to make the decision using this function. So what does this mean? It means that f of Q optimal for the buyer is going to be simply the ratio of cost of overage, cost of underage to the ratio to cost of underage plus cost of overage. So in this case, this is going to be P minus W divided by P. Okay? Now, of course, what we want is we want this fractile to be identical to the centralized fractile. So what is the condition for that? Okay, the condition should be if W is equal to C, then we can obtain the centralized quantity. What is the meaning of having W equal to C? The supplier is not going to make any profit. Okay? So in that case, you can immediately see that in a wholesale contract, actually, you cannot obtain the centralized solution with the wholesale contract. It's not going to coordinate the system. Why? Because the supplier will not be willing to cooperate in that case, of course. Why should she cooperate? I mean, the only time that the system is going to have the centralized expected profit would be the case when W is equal to C. Now, in general, I would expect W to be larger than C so that the supplier is going to have some kind of a profit. So what will this result? If W is larger than C, what can you say about this Q star of buyer compared to the centralized Q? This W is larger, so the numerator becomes smaller, the fractile goes down. So the quantity that you order in this decentralized setting will always be less than what you would order in the centralized setting. And this effect is called double marginalization. Because what's happening here is that as the supplier is trying to make this margin as the profit, and W is larger than C, it is adversely affecting the buyer. So the buyer buys less quantity. Okay. So we now see that the wholesale contract is not a contract that coordinates this system. So with the existence of a wholesale contract, the supply chain is going to be very inefficient with respect to the operations. Okay, any questions on this? Now you can see that the way that I did everything is actually I compared two profit functions. Okay, now let's move to another contract. Excuse me. Again? Okay, now W in general is expected to be greater than C.
Why does buyer increase to pay more than C?
Okay, buyer is going, well, because buyer is buying the item from the supplier and the supplier's cost is C. Now, if the supplier agrees not to make any profit, of course, then both systems are going to look alike. In other words, the wholesale contract is going to coordinate the supply chain. But however, of course, the supplier is not willing to accept the fact that W is equal to C. In general, we expect W to be larger than C. The reaction of the buyer would be order less. And once you order less, the total profit that is available in the system is less than what is available in the centralized system. Okay, now let's move ahead to another contract, and this is the so-called buyback contract. Okay, wholesale buyback contract. Now, buyback contract. So what happens is that now, in order to share the risk of the buyer, the supplier does the following. It simply says that, okay, I am going to charge you W per unit, which I know that is going to decrease the quantity that you ordered when it's compared to the centralized system. But what I will do is, if anything is left at the end of the period, I am going to buy it back to B per unit. So this is the idea of buyback contract. So what's happening here is that the supplier is actually sharing the risk of the retailer. So now you can see that here in the wholesale contract, the supplier doesn't have any risk at all. Okay? Given this quantity ordered, the supplier is always going to make a profit. Okay? It's always on the positive side. Now what it does is, in order to increase this Q value, okay, the supplier agrees on the buyback contract, which is it is going to be W per unit. Okay, so we're going to have W and B as two parameters. W would be the cost, the price of the supplier per unit, and B is going to be the quantity paid by the supplier for the leftover. And it is going to be per unit. So now, given this, what I will do is I'll try to write the cost of overage and cost of underage. Okay, because if I can write that, then I will resolve everything. So what is cost of underage for the buyer or retailer? It's again P times W. For each item that is not sold, this is what you lose actually. This is the profit margin that you lose. But the cost of overage, remember what was cost of overage? It was C per unit. But now, for the items which are left over, you can give it back to B. So we are going to have C minus B. Okay? Now this is more or less what I have. Now I can write pi D of the buyer. Okay? So how am I going to do that? Well, remember the general form. I'm going to change the board for a while. Okay? This was the general form of the news vendor problem. Okay, CU plus CO and CO. So let's keep that in mind. So what I'm going to do is I'm simply going to write it here. So here, then I will have the following. Where is that? So I'm going to have, this part is going to be P minus W, okay? And I'm going to have, excuse me, okay. This CO is W minus P, not C minus P. I'm talking about for the buyer. So this is here, I'm going to have CU plus CO. So W's are going to cancel, and I'm going to have P minus P, expected minimum of QD, minus I'm going to have cost of overage, which is going to be W minus C. W minus P times Q. Okay, now if I want to have the same Q star, what am I going to have? Now, here in these type of problems, the ratio of these costs are the ones that determines the Q value. So what I should have is, I should have the proportions similar to the proportions of the centralized problem. So let me write those two together. Now, the centralized problem, which yielded Q star. Okay, so centralized problem which yielded Q star had the following structure. We had P, expected value of minimum QD minus CQ. Okay, this is the centralized problem. And as a result, when you do the optimization, it yielded the centralized Q star. Now, what I want to have is now the pi d buyer that I wrote, which is P minus B, expected minimum QD minus W minus BQ, to give me exactly the same Q star. Okay, when I optimize it, in other words, I want the buyer to be basically selecting the same Q, that's the idea actually, of the centralized problem. So in that case, note that these terms come into a ratio, actually, PU and CU/CO. So what I need to have is, I need to have the ratio of P to P minus P to be identical to the ratio of C to W minus P. So as a result, so I can write it in the following way. P minus P should correspond to P, and W minus P should correspond to C. One thing that I know is, of course, the centralized version of the quantities are always larger, because the P that I'm going to charge in the centralized system is replaced by P minus P. So let me define lambda as the ratio, lambda as in element of 0, 1, which is the ratio of P minus B to P. In other words, I am defining that ratio. Okay? So what does this mean? This means that lambda P is going to be equal to P minus B, and lambda C is going to be equal to W minus B. Okay? So that now, I know that they are going to correspond to each other, but let lambda be the ratio that makes that correspondence. Now, as a result of this, if I can set the values for W and B in this fashion, okay, then what am I going to have as a result? As a result, the ratio that I'm looking for is going to yield me Q star. Now, what does this mean? This means that here, what are the things that I don't know? What are the contract parameters? Now, W is a contract parameter, and B is a contract parameter. So I have two unknowns. What are the things that I know? I know P, of course. I know C. Those are given. And lambda is not known. And what do you think lambda is going to be? Just now, let's say that I have equated these. So what I'm doing is actually I'm multiplying pi c with lambda. Okay? Multiply pi c with lambda, you are going to obtain similar terms that we have here. Okay, so lambda is actually proportion of the profit that will be received by the buyer of the expected centralized profit, of course. Okay? So if you apply this contract, okay, as a result of this, there will be a chunk of expected profit in the system, the centralized profit, and lambda proportion is going to be received by the buyer. The remaining is going to stay with the supplier. Okay? Now, give me a lambda. In other words, tell me how you want the total expected profit of the centralized system to be shared by the buyer and the supplier. And I'll tell you which parameters you have to use in order to make sure that that is, you obtain number one, you obtain the centralized Q. Number two, you obtain the profit proportions that you want to have. Excuse me? Well, why 0.5? Do you think that Arçelik operating with a supplier is going to be satisfied with 0.5? Probably not. Arçelik would tell the supplier that, well, if I don't exist, of course you are not going to exist, but on the other hand, if you don't exist, I will still be there with another supplier. Okay? So 0.5 is nothing actually. It doesn't mean anything under this circumstance. But you can see that at least we were able to show that buyback contract is going to coordinate this supply chain. In other words, to use a buyback contract is very meaningful. Because if you can set the parameters properly, then it means that you will be able to operate the system in the most effective way. Now, how am I going to understand the profit, the sharing of the expected total profit? Well, of course, it is going to depend on the power of different parts. Now, of course, if lambda becomes 0, then it's not something that the buyer is going to look for. So you don't expect lambda to be in extremes, but lambda can be set in a reasonable way, of course. Note that each lambda, regardless the lambda, the total profit, the profit of the buyer and the profit of the supplier will always be the same. So you have infinite number of solutions with respect to the buyback contract, which is going to yield the centralized solution, but will give different profit shares. Okay. Now you can see that if you give me lambda, I have two equations, two unknowns. I'm going to solve W and B accordingly. Okay, so two equations, two unknowns. You solve W and B. Okay. So any questions on this? Okay, now you can see that actually with buyback contract, it wasn't very difficult to obtain the solution. So this is basically what we have. Now let me go to the revenue sharing contract. Now we have seen the revenue sharing contract, but again, I'm going to simplify the way that it looks. Now, of course, you can have different types of revenue sharing contracts, but I will talk about sort of the standard one. Okay, so revenue sharing contract. So in the revenue sharing contract, W per unit is charged for each unit transferred. to the retailer, to the buyer, and the profit share of the supplier is one minus phi times P. Okay, let me see which one. Okay, so this is the share that you give to the supplier. So the buyer's revenue per unit would be P times phi. Okay? So now we have two parameters, W and phi, will be decided in the revenue sharing contract. Now this is going to yield more interesting results. So what I need to do is I need to write again note that here of course phi is going to be a number in between 0 and 1. It can be 1 as well. Okay, so what am I going to write now? I need to write the decentralized expected profit for the buyer and then compare it with the decentralized expected profit of the centralized system. Now in this case, what would be the cost of underage plus cost of overage? So let's write everything here. Now cost of underage is going to be the surplus that you are going to obtain. So this is going to be P times phi minus W is going to be what you lose if you cannot make this an additional sale. And cost of overage, excuse me, is going to be simply a W okay, and as a result, cost of underage plus cost of overage is going to be P times phi. So here, I'm going to have P times phi, expected value of minimum QD, minus W times Q is going to be what I have. Okay. Note that I'm assuming that there is no salvaging and so on. Okay, I will do the same thing when there is salvaging as well. In other words, for the items that are left over, there is no salvaging here, that you don't obtain any salvage value, but I will do that case as well. Okay, so this is actually the buyer. Now, what was the centralized, if you recall? Pi C, we had P times expected minimum QD time minus CQ. Okay, can you see what's going on here again? So what I will do is actually I am going to multiply so let's say that pi is again the proportion that we are looking for in the same way. So I'm going to have pi times P equal to phi times P. Okay? And the second one is pi times C should be equal to W. So these are the two equations, two unknowns that I have, given a certain pi. Okay, I want to decide on pi and W, but the solution to this problem is unique because you have sort of multiplicative forms here. And what is this? From this, we see that pi is equal to phi. Okay? And once pi is equal to phi, W is simply phi times C. So give me a profit share that you want to have at the end. Now, what was pi again? Pi is the percentage of the centralized expected profit which is received by the supplier, okay? Because we multiply that, okay? So pi is the, when you multiply it with pi, this is going to be the expected profit which is received by the buyer, not supplier, excuse me, okay? And so if you tell me that you want, let's say, 80%, that 80% immediately reflects to the policy parameter, the revenue share is going to be 80%. Or the revenue share of the supplier is going to be 20%, 1 minus phi. Okay? And then W is simply going to be the same quantity. Okay, so this is sort of what we obtain at the end. And note that now you can create a buyback contract. For any given buyback contract, I can create a revenue sharing counterpart. In other words, what we have in the buyback contract is we have certain proportions of the total expected profit that can be obtained by the centralized system. And you can have the same value in the revenue sharing contract as well. So what does this mean? It means that both contracts are going to yield the same solution with respect to the profit share of the centralized system. You can always have points where both contracts are going to yield the same solution. Now, what happens if we have salvage? Now, in that case, when you have salvage, cost of underage is still going to be pi, P times pi times W, but cost of overage is going to be W minus S. But what you have to assume is that you have to consider the following. If you are receiving a revenue from the salvage, you have to share it with the supplier as well. So here we are going to have phi times S coming into picture. So if that's the case, then you can obtain actually a similar solution for the system-wide case as well. Okay, so once you have these two, you can obtain the solution. Okay. Now, what we did is sort of in a very simplistic manner, what we have outlined is we have outlined a methodology to find the coordinating solution, whether it exists or not, whether it's a meaningful solution, and how the profit is shared. So this is the extent that we can do as the analyzer or a person who is doing the mathematics for the supply chain. Now, the remaining part, how this pi is going to be decided, which is directly going to affect the parameters of the contract, is basically comes from the power relation of two parts. Okay, you can see that people would be inclined to have more, of course, but then you start bargaining, and that's the part which is probably important in real life, but for us it's not that important because they are going to end up in one of the points, and I don't care actually. My role is to find out a set of solutions that would yield the centralized solution. Okay, so this is actually how I will do that. Now, next time we are going to see a few more contracts, and we're going to do the analysis of those contracts, or at least define the contracts in the reasonable way. Questions? Okay, I'll see you on Thursday.